Well, good morning, everybody. I want to thank Patrick for that introduction today. We get a lot of questions about the foundation, and hopefully if you do have any additional questions, you're always free to contact us with all the tools that Patrick mentioned. Well, we want to go on with our webinar today by title the live webinar talking about the irrigation systems and winterizing. So this is where we really want to make sure to cover some of the issues that we get a lot of questions about. So when we start doing this, we're going to find that we have irrigation systems throughout the world that people are having issues with backflow contamination at times, but we also have those areas that are concerned with how we deal with these systems when we start getting into colder weather, and how do we now protect them from freezing. When we start seeing some of the issues we'll be talking about today, the information. As Chief Engineer of the Foundation, we oversee not only the evaluation process that Patrick talked about, but we also get out and talk to a lot of people talking about various issues. So this happened to be one that we wanted to cover today. So on our agenda today, what we wanted to discuss, not only irrigation systems, some of the different types of irrigation systems, but also what is the actual degree of hazard? What are we guarding against? There are some jurisdictional issues we want to address, knowing that many of you are wearing different hats, either as private contractors or administrative authorities. We want to make sure we're clear on some of those issues. We'll talk about the backflow prevention assemblies themselves, those that are suitable for this particular application with irrigation systems. And then finally, we want to follow up with freeze protection. I mean, when we're starting with some of these systems, a lot of people don't understand that they do have to protect them from freezing during certain parts of the year. So we'll talk about some of those winterizing type issues and hopefully answer the questions that you have. So when we start talking about irrigation systems, we really want to start talking about various types of irrigation systems. When we start looking at these systems, we could probably break them down into a couple of basic categories. One from just agriculture as compared to landscape irrigation. And when we're starting to deal with these, we'll break that down into both residential as well as non-residential type applications. When we start looking at agriculture, this is where typically many people involved within the cross-connect control industry may not have a direct contact with this type of application, because generally this is not a system that's directly tied to the water distribution system itself. We normally have agriculture pulling water out of groundwater, surface water, and then using that in a variety of ways. Flood irrigation, as shown in the picture to the right, and then more typically when we're starting to deal with some of the landscape irrigation, it's similar to what you're going to find in agriculture applications, where we have sprinklers, where either these are hand moved, where the piping themselves are moved throughout a field, or the automated center pivot and other type of automated systems that are now irrigating that agricultural application. Interesting, when we start looking at these type of applications, you may say, well, since it's not a direct connection to my water distribution system, is there any need for backflow protection? Well, keep in mind that these are being primarily fed from wells, and there is a primary concern that when the system does shut down, that we don't have any of the irrigation water, which may be chemically treated, flowing back down into a well. So there are actually backflow preventers, or which are called chemigation backflow preventers, that have been developed for years that have been primarily used on these agricultural type applications. So here are some pictures showing a typical chemigation valve. There is a standard from the American Society of Agricultural Engineering, the EP 409, which discusses and identifies the various components of this product. You can see that it doesn't look like our conventional backflow preventer, be it a double check or a reduced pressure principle assembly. So it is a little bit of a different type of product. You'll see that these have been primarily preferred by the people who are using them on agricultural type applications because they tend to have a lower pressure loss than the backflow preventers that we're dealing with distribution systems, where we typically think of our backflow prevention assemblies with head losses for like double checks of no more than 10, and some of the reduced pressure principle assemblies with higher head losses. In these agricultural applications, many times they feel that the pressure even coming off of the wellhead may be rather low, and they can't tolerate even any increased pressure like we might find in a conventional backflow prevention assembly. So this is where we find that these have been used due to primarily lower pressure loss. And in many of these may be check valves that have less than a 1 psi loading on them. And there's only a single check, as you can see in the illustration on the right. There are other components where there's a means for venting air and draining water out of the unit. So it's kind of have some of the components we may see in a conventional backflow prevention assembly, but it is a different type design. It is noted, though, that in many of these designs, they're not considered inline repairable. To actually get to the internal components, either the entire product has to be pulled out of line to work on, or in some cases, we've actually had reports from the field where they have to cut openings in the bodies so that they can pull internal components out. So this, again, we just want to make sure we differentiate from what we'll be talking about today, which primarily is going to be dealing with landscape irrigation systems. And now we get into more of the type of applications that many of us are probably familiar with, dealing with either sprinkler type systems, drip irrigation systems, or subsurface landscape irrigation systems. So we'll be concentrating most of our discussion today on this type of an application rather than the agricultural that I just mentioned. When we start thinking of sprinkler systems, I think most people can relate to it. You may have one at your own home or place of work. We think of sprinklers as either pop-up sprinkler heads or big impact heads, cannons that are now been able to distribute water over a specific area. So this is where we find sprinkler systems are probably very common and what many people are dealing with landscape irrigation. We have seen a distinct increase in the use of drip irrigation for a variety of reasons. We know drip irrigation has its advantages, getting the water right to the plant under very controlled conditions, and also we can conserve water. Instead of spraying over a large area, you can get water directly on the point of use. Subsurface landscape irrigation, again, you may find in some areas where the actual irrigation water is not being dropped on the surface, but is coming from underground and maybe so much like a leach field where they're now bringing the water to the underground area to plants. What's kind of interesting with the subsurface type landscape irrigation systems, you may be familiar with gray water systems, which really is considered a subsurface irrigation system. In many areas that have had water conservation issues, for those of us here in the Southern California area, we've come off a number of years of very dry conditions, and we've had many cutbacks in the water being used for irrigation. So there's been quite an increase need for alternate water supplies. So gray water systems, which are detailed in many of the plumbing codes, illustrate how somebody can remove sewer water from their house. Typically, though, when we talk about gray water, it's something that has coming off of a particular usage in the home, quite typically coming off of a washing machine at high volume, but does not have direct contact with sewage, such as from a toilet or other applications there. So in these situations with the gray water systems, you'll find where that gray water is being collected and then used as a subsurface irrigation water. So we're not going to be specifically talking about these today. We've had other webinars where we've talked about dual plumb systems, and we do mention a little more detail about the gray water systems. So we get back to some of our irrigation and landscape applications. But I think probably one of our issues that we deal with quite frequently, that's a big discussion, is the actual degree of hazard. What are we guarding against when we start dealing with irrigation systems. And this is where we see some debate on what is actually the hazard we're guarding against. If we think of irrigation systems, I think we typically think of additives being coming with the irrigation water, fertilizers, herbicides, pesticides, all being directly added to the irrigation water for a very obvious reason. One, we're getting the actual material right to the point of use. It'll maybe improve the yield of whatever they're watering, improve the growth of whatever's being irrigated. It's also going to conserve water. We can then make sure to get the water right where we need it with the appropriate additives going into the system. And it becomes very cost effective. So this is where we find many irrigation systems. The additives to the irrigation water itself may be one of the areas that we're concerned with when we're dealing with backflow prevention. Obviously, when we start talking about additives, as noted above, a health hazard or a contaminant is where most would categorize all of these hazards. So I think in irrigation systems, we're going to find the degree of hazard is typically considered a health hazard. And because of that, that's going to be a big impact on what type of backflow protection is properly used on an irrigation system. How are these additives getting into the irrigation water? Well, we're going to find a couple of different ways. Additives can either be pressurized systems, as shown in the upper picture here, where there is a pump that is taking whatever additive, the fertilizer or herbicide, whatever may be added to the irrigation water, and it's pumping it into that water line. So in this case, we would consider the potential for back pressure because we have a direct cross connection. That it would be one consideration. On the bottom picture is a different type of way of adding water, the chemicals to the water system, where it's not being pumped in, but rather it's being siphoned into the flow of water. The water going through the pipe in the lower picture as it flows through is actually going through a little aspirator. And with the flow of water, it'll create a siphoning effect, which will draw the chemical out of the tank into the irrigation water. And this would be deemed an indirect cross connection because the tank is not creating a back pressure. It is only when water is flowing that would create a back siphonage type of a condition or a low pressure and pull the chemical directly into the irrigation system. So we want to make sure we separate the two, where we're creating a back pressure or direct cross connection versus an indirect cross connection, which is back siphonage only. And as we start talking about the different types of irrigation systems, you'll see that this will impact our choice of what is the appropriate level of backflow protection. Excuse me. We also have to talk about the actual outlet of the sprinkler. When we start talking about irrigation systems, we know they're exposed to the elements. So it isn't just chemical contamination, but we now have biological hazards, things that could just be landing on the ground around the sprinkler head, and this is something that has to be looked at very carefully. The outlet of that irrigation system is subject to contamination. So it isn't just the additive of putting a chemical into the system, but the rest of the irrigation system. And I think most would agree that based on these type of biological hazards, which may be present, it would definitely then consider that degree of hazard to be contamination.